Hey Houston, we don't have a problem. Today we're starting a brand new unit. This is a unit about something called topographic maps. What's a topographic map? It's these maps with all these cool lines. We got the browns and we got the blues, we got some greens, and we got lines everywhere. What is the point? Well, that's what we're going to learn about. Maps are important. From our faith tradition, Joshua 18:8 said, as men started on their way to map out the land, Joshua instructed them. He said, go, make a survey of the land and write a description of it. So Joshua said, go map out the land and then return to me, and I will cast lots for you here at Shiloh in the presence of the Lord. So this is an important part. Mapping is biblical. There you go, right? Hey, today, or in this unit, we're going to learn about, three big things. We're going to define what a topographic map is and what it's used for. We're going to describe how contour lines show the elevation, shape, and slope of the land. More on that later. And identify the meanings of some of the symbols and the colors used in topographic maps. So what is a topographic map? Here's the big deal. What does it do? A topographic map, it shows the shape and the elevation of the land. So here in Houston, it's flat. But in other parts of the world, it ain't so flat. I used to live in Colorado. It's not flat there at all. And so you can actually look at the map and you can say, oh, there's a mountain here, and there's a valley here, and a stream there. And you're going to know how to do that by all the times you get to practice reading the maps. What are they used for? Hey, soil conservation. Remember in our previous units, I would say, we've been learning about what soil is, but soil moves downstream, right, through streams. And if you know the slope of the land, you can figure out where it's going. Also used in crime solving. Really? Yeah, because it helps you to find things. You can know where things are. Emergency response planning, especially in terms of landslides and some of the mass wasting things we've talked about earlier. And marketing and real estate. Man, you could look at a topo map and you can say, this spot here is going to have the best view on the planet because it overlooks a big mountain or a stream or something like that. So a lot of interesting uses of topographic maps. So let's define probably the most important term. The most important term in all of topographic maps is this thing called a contour line. A contour line is a line of the same elevation. So if we look at this sort of topo map, this line that I'm chasing right here, this line right here is a line of the same elevation. And it actually tells me the number. It's 1040. I'm going to say that's feet. I don't know for sure. We'll call that 1040 feet. And this is 1060 feet, right? So if I was to walk from here around this circle that I've just drawn, or not quite a circle, I guess, but on this path, I would be walking at the same elevation. But if this is 1050 feet, right, this particular line, that means that this is 10 feet higher. So if I were to walk from here to here, I would be walking uphill. And of course, this one would be 1020. And if I was to walk like this way, I would be walking downhill, and I would go 20 feet. You see how that works? It's called a contour line. There's some other terms that are important when we talk about topo maps. The scale. All right, that's how there's 1 inch is equal to 1 mile or whatever it might be, or centimeters or whatever it might be. This is important so we can know that the relationship to that. The legend explains many symbols that are used on the map. I'll show that a little bit later. And the contour lines that are labeled, these are called index contours. They're labeled to help you find the contour interval. Now, in this last one, they were all labeled, but let's take a look at some other ones and we'll see. All right. Now, again, contour interval. Let's just dive a little deeper. It is the difference in elevation between two contour lines that are side by side. All right. So this contour interval, important term, contour interval, okay, is the difference in elevation between the two. Remember, contour interval is not the distance between the two lines. You get that with the map scale. It's not the distance between the line, it's the elevation difference. Okay, so let's make sure we understand that. Okay, so here is 600, and here is 610. Does that make sense? So the difference in elevation between this spot and this spot is 10. Does that make sense? But also the difference in elevation here and here is still 10 feet. But obviously if I travel from here to here or from here to here, that's a different distance. Does that make sense? If I was to walk, that's a very short distance, but I would go down the same 10 meters or feet, I don't know what the units are on this, or here I would walk further, but I would still descend 10 feet. Now, by the way, how do I know it's descending? Because I went from 610 to 600, right? So that makes sense, right? All right, so let's talk about the meanings of these lines in terms of what happens when they're close together. So when they're close together, that means that it's really, well, what do you think? Think about it. Think. So if I was to go from here to here, okay, that's lots of contour lines. I would be going from 670 feet to 580 feet in a very short space of distance, right? You know what that's called? That's called a cliff. You'd be jumping off, splat. You would jump off a cliff. That would not be a good thing. Hopefully there's some water there and you're cliff diving. But this is a contour interval. The contour interval, by the way, is 10, 670 to 660. That's the contour interval between the two lines. Does that make sense? And that's the difference, all right? And it would be, well, let's think about this. What is it if they are far apart? So now we're going from here to here, and that's a much further distance. This is the cat walking. I'm walking down the street one day. And as you're walking down the street, you are descending slowly from 680 to 670 to 660. So it's a longer walk. So this is a gentle, so when they're far apart, we call that a gentle slope. Now, how do I know if I'm going up or down, right? How do I know that when I go from here to here, that's going up, and going from here to here, that's down? That's because, of course, the numbers get bigger or the numbers get smaller. Let's take a look, though. One more thing I want to point out from our first screen here. It's a little bit more complex right here. When we have, this is a much more good example of a what you call it, map, a contour map. Let's take a look right here. All right, this is 7,200 feet. Okay, we're somewhere, I don't know where we're at, somewhere in the world. And I want to find, we call that's an index contour. Does that make sense? Actually, let's do this one. I see this might be easier. This one's 8,400, and this is 7,200. Does that make sense now? And what I want to do is I want to find out what does each line, each contour interval represent. And so I need to find indexes that are close to each other. And let's see. So I've got one darker one, two darker ones, and three darker ones. So this is 7,200. Let's do a little math here. 7,200, and we have 8,400. So the difference between those two is 1,200 feet, right? And so the question is, what does each of these dark lines represent? So this is 84. I think it's 200, isn't it? 82, 8,000. No, it's not going to work. It's 400. So it'd be 1,200 divided by 3. So 3 times, so it's 400 feet, right? Let's make sure I can do this right. 8,400, this would be 8,000. This would be 7,600 and 7,200, yeah. So they're 400. The indexes are 400 apart, all right? But each little line, all right, so between the little lines, let's go from here to here, there is 1, 2, 3, 4, 5, right? So there's 5. 400 and 5 goes into 400 8 times, or actually 80 times. So each line here, between each line on this graph, is 80 feet. Does that make sense? So if I was to travel down from here to here, I would travel 400 feet, and each would be 80 feet at a time. So the contour interval on this map is 80 feet. The index contours are 400 feet apart, the darker colored lines. You might ask, Mr. Bergmann, why are some blue and some are brown? Well, the blue indicates that it's ice. So this would be an ice field, a glacier, the Emmons Great Glacier, as you can see. And this would probably be forested land, or it may not be forested, it could just be bare rock. Now, let's just ask an interesting question right here, just as it's related. I'm trying to find the steepest place on this graph. Where's the place that's going to be, you want to fall off? I think it's actually Baker Point, and if you go from here to here, it's a very short distance, and there's a zillion lines there. That would be a cliff, and it would be very dangerous. So if I wanted to get to Baker Point, what would I do? I'm trying to think, how would I climb this to get to Baker Point? I'm going to try and get the shallowest. I'm going to come in this way. something like that, and I'm going to have to find a place where it's flatter. And I don't know, it's hard to see. I'm probably going to come across here. It's obscured by this white thing. That's probably how I'm going to get to Baker Point if I wanted to go take a gander and take a cool picture. Okay? Hey, that's video 1 of 2. Next we're going to learn how to use them. Houston? We don't have problems. We'll see you in class.